So hello and welcome to the walkthrough series, and in this episode we are looking at the 9618 variant 41 May-June 2021 P4 question number 2. We did look at question number 1 in the previous video, so now we're moving on to question number 2. So without wasting any more time, let's look at what we have going on number 2. So it says here that a program stores the following 10 integers in a 1D array with the identifier array data. So those are the 10 numbers. Then part A says here that write program code for a new program that's going to declare the global array, global 1D array rather, with the identifier array data that's going to hold 10 elements. Then we are to initialize the contents inside of the main program using the data values shown at the beginning of the question right there. So let's look at the solution. So the way you are going to go about this is to declare your code, rather to declare your array inside of your classes. It's sort of like as an instance variable, rather is a global attribute. So the way you are going to do that, you can look at line number 7 right here, that we have a public static integer array called array data. That is the identifier that they instructed us to use for our array, and it's going to hold 10 integer elements is indicated by that 10 in the box brackets there. So this is how you go declare global array right inside of in a Java code. So you want to declare the array outside of any method but within the class, as it were. Then you also want to make sure that you make it static so that it's not it's an instance variable. Basically it simply means that this array belongs to the class. Then we are to initialize array data in the main program using the data values shown. So these are the data values that we are supposed to use right here. So we need to initialize this inside of the main program. So whenever you see main program, they are referring to you writing the main method in Java. So you see that here we are now initializing the data values given by making use of our array. So we are making use of the array index values and assigning the values that we've been given in the question at the beginning of the question right there. Then once you're done, you're going to go ahead and copy this code and paste it inside of the evidence document as instructed right there. Then number 2, part B, item 1 says that a function linear search takes an integer as a parameter and performs a linear search on array data to find the parameter. It returns true if it was found and false if it was not found. Write program code for the function linear search, and we are going to be awarded 6 marks for doing this. So let's actually go ahead and scroll down to lines 37 and 44. Between lines 37 and 44, that's where I have my linear search function going on right here. So you see that my identifier linear search, right, and boolean is my return type, because we were told that it's going to return a true or a false depending on whether the element was found or not. So our return type is going to be boolean, and they said that it takes an integer as a parameter. So we have our parameter, the identifier for our parameter is going to be search item, is it, and it's of type integer. Then we are simply using a simple for loop that's going to iterate through the array and look for the particular search item that would have been passed as an argument when the linear search method is called. So if we encounter that particular rather, if the current array element is equal to the search item, then we are going to return true. Otherwise, if we don't find anything, the linear search function is simply going to return false by default. That is in the event that it doesn't find the search item inside of the array. Then for this we would get 6 marks. Then you would go ahead and copy this code and paste it inside of your evidence document. Then moving on to item B, item 2, we are to add the main program to allow the user to input an integer value, pass the value to linear search as a parameter, then output an appropriate message to tell the user whether the search value was found or not. So let's go ahead and look at this, the implementation of this. So starting from lines 22 up to lines 34, that's where we have this functionality that's described in this case, and for that we are going to get 4 marks. So let's see how you can get these 4 marks. So essentially you're going to need a variable that's going to hold whatever the user types in, is it. So we have this user value variable right here, Then we are also going to need a boolean that's going to hold the result of whether the user typed value is contained in the array. So we are going to store that status or that boolean result in this variable called result of type boolean. Then we are instantiating a scanner object right here called keyboard. Then we then prompt the user to type in a value to search, after which we use the keyboard object to get the next integer from from the keyboard and store it inside of the user value. Then we are closing the scanner, the keyboard object on line 28. Then we call the linear search method by passing it the user value or the user input value. At which point the linear search, remember the linear search function, it returns a true or a false, is it? So it's going to return either a true or a false. Then we are going to hold that particular value inside of result. Then in the event that result is true, we are going to output search item is found. Then otherwise we are simply going to output that the search item was not found. That is to say, if the result is false, so it's going to run this else statement right there. So that would do it for the 4 marks, and you would go ahead and copy this code and paste it inside of the evidence document. Then moving on to item 3, B item 3, it says here that test your program with one value that is in the array and one value that is not in the array. Take a screenshot to show the result of each test. So we will go ahead and run the code, run our code. So let me see if I compared it earlier, Java question 2. So type in a value to search. So we know that 10 is in there. So you will see that it outputs that the search item was found. Then we are going to run the code one more time, and by looking at these values, we know that we don't have 45 in there. So if we hit enter, it should rightfully say that the search item is not been found. So you would go ahead and copy and paste these results, rather this is the screenshot inside of the evidence document, in order for you to get the 2 marks. So I suppose it's actually 1 mark for each run. So 1 mark for inputting a value that's actually in the array, then another mark for inputting a value and getting the correct output for an element that is not in the array. Then let's move on to part C. Part C says here that we are given pseudocode, is it? And essentially it's a bubble sort in essence, and we are supposed to translate the bubble sort into from pseudocode into program code, as it were. So let's go ahead and scroll down to where we have the bubble sort algorithm. So I'm not really going to explain how bubble sort works. I think I have a video that explains how the bubble sort algorithm works. You can check out my animated series where I have the animated demonstration of how bubble sort works. But essentially, we are supposed to complete these dashed statements right here. So this is the completion that we have right here. So you see that the bubble sort function, it simply uses 2 loops as well as an if statement, is it? So we have the outer loop that is going to do the run or the pass from the first element in the array to the last element in the array. Then the inner loop is essentially going to compare the 2 adjacent values, is it? For how best can I explain this? Again, I think maybe it might be a good idea, if you don't really know how bubble sort works, to check out my animated video. But essentially, this one is handling the outer, the run from the first element to the last element. Then this is actually running the comparison. So the inner loop is responsible for comparing adjacent elements, as it were. So essentially, what we are simply doing is that we take the current element and put straight inside of temp. Then if the current element is equal to rather we are assigning the element that is the next element to the current position. Then we move the next element that we put in temp and put it at basically this is just a good old variable swapping. what's happening between lines 52 and 55. It's just good old variable swapping, but this swap is just going to occur if the current element is greater than rather is less than the next element. So let's say maybe in our case, if you look at 10 and 5 right here, it means that 10 is not less than 5, right? So it means we need to swap these variables. So we would take temp and put it inside, take 10 and put it inside of the temporary variable, then move 5 to where 10 was, and then take 10 from temp and put it to where 5 was. Essentially, that's what we are doing with this segment of code right there. Then for the bubble sort implementation, or rather completion of bubble sort, you would get 6 marks. Then yeah, as it happens, that's the end of question 2, and also the end of the video. So I'll see you in the next one.